Firebase Realtime Database is a simple and affordable way to store unstructured data that updates frequently. Let's walk through how to set it up. We'll build a personal details page with fields for name, email, nickname, and bio. We're keeping this prototype simple, so no AI features, just the core stuff. All right, there it is. We can try editing the profile now. It works, but since this is only a prototype, the data is stored as hard-coded values. That means our next step is creating a Firebase backend. And it's ready. Let's try editing the profile again. The Save Changes button doesn't do anything. That's expected though, because we still have some backend configurations to make. Let's switch to the code view to see what we've got. Even though the Firebase API key isn't strictly sensitive, it's good practice to save it in the .env file. You should always do this if you plan to publish your codebase publicly on GitHub. In the Firebase.ts file, we can also see the database URL. It might be correct, but we'll fix it later. Clicking this button takes us to the Firebase backend. If you're unsure which database to pick, here's a quick comparison. Firebase Realtime Database works well for things like chat messages, since you're saving a lot of small pieces of data. It's also cheap because you only pay for the storage space, not for each read or write like in Firestore. Now let's create the database. First, pick a location. I'll choose US Central. Then, you need to select either locked mode or test mode. Test mode is open to everyone and anyone can view, edit, and delete all the data in your database. We'll select locked mode for now and open it later. Here's the database URL. Let's copy it. I'll let Gemini know that we've created the database and share the URL so it can update things if needed. Now let's try editing the profile again. We get a permission error. This means our database request probably found the correct database, but permission was denied. That happened because the database is still in locked mode. Let's open the database for everyone. Never do this in production, since anyone could steal, change, or delete your data. This time we don't get any errors. Let's check the database. And there's the data in Firebase Realtime Database. That was easy, but obviously not secure since the database is public. All right, let's set up authentication. We need to do this so that only authenticated users can access their own data from the database. I'll quickly enable Google Authentication. If you want a more detailed tutorial on setting up authentication, check out my channel. I'll just set this up fast. Then I'll ask Gemini to add a sign-in button. And there it is. The button doesn't work yet because we need to add the web app's address to the authorized domains. Let's do that real quick. Now it's done. Let's test it. It looks like it's working. Let's check the database. The data is now stored in the users folder. Inside it, each user has their own folder with what looks like their user ID. If we had multiple users, they'd all be separated into their own folders. Now that the app works with authentication, we still need to set the security rules correctly. There are some great examples in the Basic Security Rules section of the documentation. There are tabs for Cloud Firestore, Real-Time Database, and Cloud Storage, so make sure to pick the right one. Here's a rule that allows all authenticated users to read and write. That's not what we're looking for. Here's a better example. Content Owner Access Only. It requires the user to be authenticated and their UID to match the current user's UID. We just need to change some underscore path to the correct one, which in our case is users. The rules are ready, but let's double-check how the app writes data. The path is users, then UID, and then profile. Our rules are still good. We don't need to mention the profile folder because the rules will cover subfolders as well. Let's see if we are still able to edit the profile. We don't get any permission errors, and the data ended up in the database. Next, let's talk about data validation. We can set a validation parameter that checks if the data is in a certain format. For example, here, the new data must have a child called ranking. Here's a better example. The value of the size field must be a number between 0 and 99. So, let's ask Gemini to give us security rules so that the name and nickname fields contain only alphanumeric characters. That's a good safeguard against things like cross-site scripting or database injection attacks. Gemini wrote the rules to a file. We could send this to the backend with the Firebase command line interface, but I'll just copy and paste it into the console web page. Let's try it out. We get a permission denied error just like we wanted. Now let's talk about indexes. They're critical for performance, especially if you're querying lots of data by a specific field. You don't need them during development, but always define them before deploying to boost query speed. Here's an example database about dinosaurs, where you might index fields like height and length. For our current app, indexes aren't necessary since each user only queries their own data. But let's add a new feature. We'll create a status post field where the user can post their status to a status feed. For that, I'll create security rules so that there's a status post path that can be read or written by only authenticated users. I'll copy those rules and pass them to Gemini. Now I'll ask Gemini to add a status field where users can post updates and save them to status post path in the database. At the end, I'll paste our new security rules. We were able to post a status. Let's see what we got in the database. It looks like we got it right. The data is there. Next, let's have Gemini add a button that opens a status feed page showing posts from all users. And there is our new status feed. Imagine thousands of posts appearing here. Without indexing, queries would get slow. Let's add indexes. We'll choose the timestamp and username fields. The timestamp is good for general querying of values, and the username is useful in case you want to search for posts from a certain user. After refreshing, the page feels faster, though with only one post it's hard to notice. Still, always set the right indexes before deploying. Just think about which fields you'll be querying and sorting. That's the full walkthrough. If you found this useful, share it with your friends. Happy coding!